Hey everyone, this is Steven, StoicDev0 on Twitter. I am a Solidity dev at Remark, co-author of the EVM implementation of the protocol, together with 3 merged EIPs. This video is part of the first project series where I teach you how I build Snake Soldiers. Remember, this is a personal project, it just happens to use Remark. In the previous video, we created a new repo from the template and started customizing it to our needs. In this video, we will add the functionality to add assets to tokens. Adding assets is a 3-steps process. First, we need to add the asset to the contract, then we need to add it to a token, and finally, the token owner needs to accept it. The ready-to-use implementations all include these methods, so I will just go to one of them. This is the abstract implementation for Equipable. All the 3 versions of the ready-to-use implementations use this. So remember, every time we see abstract, this is a semi-implementation. So I will just take what I need from here. I want to add asset to token, add equipable asset entry. This is maybe a bit in disorder, and add asset entry. So this way it looks much better. We see that we are missing the total assets. Let's also copy it from here. Be good now. And finally, I will explain this next, but we will also need a way to set valid parent for Equipable group. You might wonder, why do we have the first 2 steps to add an asset to a token? Why not just add it directly to it? I'll explain with an example. Let's imagine this is a collection of swords and that there are 5 types of swords. The max supply of the collection is 1000. If we had a single step, we would have to store the metadata for the source 1000 times. Storing data is the most expensive operation in Solidity, and strings may take several slots. With this 2-step pattern, we store the metadata only 5 times and then store a reference to the asset ID on the token's assets. Ints are much cheaper. Next, why do we have 2 functions to add assets, and which should I use? The first version comes for the multi-asset Lego. It simply adds an asset which can be added to any token but has no equipable logic. If we want to add an asset that can be equipped to another one or that can receive other assets, we must use the second version. Equipable group ID is a way to group different assets that will have the same behavior. Going back to the swords example, let's also say that all of them can be equipped into another specific collection. We want to make sure that only valid equips can happen, so we need to tell the contract that all of these swords can go into a specific collection at a specific slot, but we don't want to do it 5 times. We want to avoid spending gas as much as we can, so we just give all of them the same equipable group ID. Then we will call setValidParent for equipable group to tell the contract that every asset with this group ID can be equipped into a parent at some specific part. When adding equipable assets, we also have the catalog, which defines fixed and slot parts, and the part IDs that this asset will use. Catalog and part IDs. I will be adding a video explaining the catalog more in detail. For now, just note that they define a set of fixed parts which any asset can use to compose itself. For example, I can have all the arms, heads, bodies and legs defined just there and cherry pick them here if I don't want to generate the composed version of Shane. Slot parts, on the other hand, represent what an asset can receive. For instance, Snake Soldiers will use 3 slots for gems and some more slots for weapons and armor. Finally, you can see that all these new functions I added are gated as only owner or contributor. Contributor are addresses that can be added by the collection owner to do certain operations. This might come useful in the future for collaborations, so I will use the same, but you can adapt it to your needs. Let's check the implementations. We keep track of the total assets, so we auto-assign the ID. You can see we simply call internal functions. You will find the package provides them for several operations. Here, there's an out to accept enable if the person adding the asset to the token owns the NFT. We could actually out to accept every time, but we want to give the control to the token owner. Next, I will override the function to get asset metadata. I want to enable enumerable assets. This is a common pattern on regular ERC 721s where you just add the base URI and append the token ID at the end. This way, if I need to add a different asset to every token, I can do it by creating a single enumerated asset and add it to every token. Compare that to adding one asset per every token. It's almost twice the operations. I will override the function here. You see I'm overriding two contracts. It might be tricky to know exactly what you should be overriding because we use several levels internally to avoid code repetition. But this interface should usually tell you what you're supposed to be overriding. Let me just comment this so I get the actual error. You see it tells you should override these two, abstract multi-asset and eRemark multi-asset. So I will just leave them there. I need to have this one also, which is a mapping from asset ID to whether it's enumerable or not. I will be using ints here. 0 will mean false. There is the boolean type, but it's usually more expensive in both gas and size of the contract. I still have an error. I don't have a method to convert unsigned ints to strings, so I will use the string library from OpenZeppelin, and I will add this. Now it's all fine. Now I need a function to define whether an asset is enumerated or not. By default, since the default value for ints is 0, it will be false, but I may want to set it enumerated or to turn it off. So we simply do this. A good practice is to run prettier after this. I forgot to do it last time. And then let's just check the size of our contracts. This will compile it, so we do two things at a time. All good with our contract. And that's all for this video. Thanks for watching. In the next video we will see how to add minting by phases and how to add ranks for soldiers, also known as tiers. Thank you. Bye.